Picture the view of Earth from space. Beautiful, right? What colors do you see? Besides the blue of the oceans, the dominant color of our planet as we know it is green. But imagine a time when the Earth looked a little purple. All that green we see today is because of chlorophyll, the pigment that plants use to harness the sun's energy through photosynthesis. Chlorophyll looks green because it absorbs the blue and red parts of the visible spectrum to use in photosynthesis, while reflecting green light. But the fact is, the sun actually emits more photons in the green wavelengths than any other part of the visible spectrum. And this has biologists puzzled. Why didn't living things evolve to take advantage of all that literal green energy by absorbing green light instead of reflecting it? Well, scientists think that green light is so plentiful that absorbing all of its energy would actually be harmful, causing damage to the pigment, similar to a sunburn. But another more interesting explanation has been proposed too. It's called the purple Earth hypothesis. So the idea goes, maybe the very first photosynthesizers on Earth didn't use chlorophyll at all. Instead, maybe they used another simpler light-sensitive molecule, one that did absorb all that abundant green energy and reflected purple light. This idea is at least plausible because such tiny lavender forms of life exist on Earth today. They're called halobacteria. Halobacteria aren't actually bacteria. They're archaea, single-celled organisms that mostly thrive in extreme environments where almost nothing else can live. For example, they're known for living happily in concentrated salt solutions. Their membranes contain a light-sensitive pigment called retinol, which absorbs green light, making it appear purple as a result. Retinol is a simpler molecule than chlorophyll, and it's easier to produce while making the most of that abundant green light. So the purple Earth hypothesis suggests that back in the Archean Eon, before chlorophyll was even a thing, Earth's oceans may have been dominated by microbes that were a lot like halobacteria, ones that use retinol or some other purple pigment to harness the sun's energy. This idea was first proposed in the mid-2000s by microbial geneticist Shil Desarma at the University of Maryland. He says his hypothesis might help explain why today's photosynthesizers don't absorb the green light from the sun, because they adapted to a world where an abundance of other organisms were already monopolizing it. According to the purple Earth hypothesis, chlorophyll eventually evolved in a different competing lineage of microbes to take advantage of the wavelengths of light that purple archaea weren't using. Picture a mat of green chlorophyll-based microbes underneath a raft of purple retinol-based microbes, soaking up the leftover dregs of light. In this scenario, halobacteria, or something like them, could have been among the earliest forms of life on our planet, and their world would have been very different from the one we know today, hot, bombarded by UV rays, and rich in sulfur and methane. Unlike today's chlorophyll-using photosynthesizers, these organisms wouldn't have produced oxygen. In fact, they would have thrived in the oxygen-deprived environment of early Earth. That is, of course, until those lowly chlorophyll producers started taking over. Chlorophyll is a more complex molecule than retinol, and it doesn't soak up those abundant green wavelengths of light, but it is more efficient, making better use of the light that it absorbs and converting more of it into usable energy. And in the long run, that's what may have mattered most. Of course, this is all speculation. The fossil record is pretty limited when it comes to microbes from billions of years ago, so the purple Earth hypothesis can't yet be proven either way. But it does fit with what we know about the atmosphere of the early Earth. For instance, we know that around 3 billion years ago, there was barely a trace of oxygen in our planet's atmosphere, so there couldn't have been a lot of chlorophyll-based photosynthesis going on. But we also know that about 2 billion years ago, some microbes that did use chlorophyll, like cyanobacteria, came on the scene and began to flourish, releasing tons of oxygen. That flood of oxygen would have killed off many of the simpler, possibly purple microbes that came before them. This microbial carnage came to be known as the Great Oxygenation Event, which we've talked about before. But if Desarma's hypothesis is right, then why are there still halobacteria and other archaea around today? Wouldn't they have been wiped out? Well, his work suggests that some crafty halobacteria may have managed to snatch a few genes from the DNA of other microbes that allowed them to survive in the presence of oxygen, which has helped them persist into the present. Again, it's all speculation, but a purple Earth is fun to think about. And if this idea is true, it could also have big implications for the search for life on other planets. One way we seek out other living worlds is by looking for planets that reflect less red light than we'd expect. This could mean they have organisms with chlorophyll that are absorbing those red wavelengths. But if life can evolve with more than one way of making energy from light, maybe we shouldn't just be searching for planets that are green like ours. Maybe we need to be looking for purple worlds as well. What do you want to know about the story of life on Earth? Let us know in the comments, and don't forget to go to youtube.com/eons and subscribe. Now, don't stop exploring. Check out some of our sister channels from PBS Digital Studios and find out what you'll discover next.